Over the last 3 years at CWNP, we've spent a lot of time researching and studying IoT protocols. And of course, most of that has been me. And I've spent a whole lot of time looking at them. And I probably know more about them than I want to know about them necessarily. But the interesting thing that I found is that they all work a little bit differently, and they all have different use cases, and they all have different applications. And they actually bring a lot of value to the wireless space. Well, in this session, we're going to be hearing from Landon Foster, who wrote the chapter in our CWICP study guide on the same topic, talking about ISA100.11a, a protocol based on 802.15.4 that can actually be used as an IoT wireless protocol in industrial environments. So, Landon, tell us what you think about this protocol.
Hi everyone, and welcome to Wireless Technology Forum, WTF, excuse me. It gets me every time. WTF 20, and the glorious year of 2020. My name is Landon Foster. I usually do my work through my consultancy, ASI Wi-Fi. I'm currently working through a company called GDT, and I have another customer which I will leave out of this. You may be able to figure out who it is, you may not. I would encourage you to just kind of leave it there. That said, my customer has given me cause to work through a deployment with them. It's been a mix of IoT and traditional Wi-Fi. So I've been overseeing from a consultant perspective both of those, whether that be design, implementation, pretty much the whole spectrum, all the way from the initial surveys to getting the APs out to doing a validation survey. It's been a lot of fun, and I've learned some things along the way. But one thing that I had to learn for this, a little before this, truth be told, is dealing with more IoT devices. For those of us who are wireless engineers, we're a little behind on this one, I think. I think CWNP would agree, and some other of you out in the audience are going to agree, that we need to catch up. These IoT devices, they're not Wi-Fi. The PHYs are different, the MAC layers are different, how they're deployed and they work are vastly different. You've probably noticed at this conference, and some of you have already done your boot camps, it's just a huge paradigm shift for us. So I wanted to talk about one of those, which is ISA100.11a. For brevity, I will be referring to it as ISA from here. That is not the full name, obviously. It's the name of an organization who originated the standard. We'll talk about that in a second. But it's just easier. For those of you who love brevity, I have bad news as well. I have one of the longer speaking slots, so settle in. I titled it A Third Way for Industrial Data Gathering. Those of you who listen to that sort of thing are kind of familiar with the term third way. I chose to title it that because there's two main camps that I've kind of seen. It's wireline and traditional wireless. You were seeing a lot of traditional wireless come out. Now the 2.4 chips in particular are getting cheaper, and even some 5 gig. I'm not happy about the domination of 2.4 in the Wi-Fi space. Not in general, don't start fighting yet. Someone back there has a sign that says 2.4 is dead, just ignore them. Anyway, one camp is the traditional wireless. I'm sure most of you know and love. And the other is something we don't see as wireless engineers or people who work with Wi-Fi very often. They run on traditional wireline. And those two ways are how they get their data back generally. So that's what makes IoT so interesting, because it's not Wi-Fi. It's not really proprietary wireless. It's more standardized than that in most cases. So it's kind of in the middle, or third way. You don't have to go left or right. You can keep on going forward. That's not a propaganda endorsement, by the way. So ISA 100.11a. Promises. Well, okay, I can't promise you, but it'll probably be the last time I'll say the whole thing. So it's been created by the ISA, International Society of Automation. They're a conglomeration, I'm given to understand, of about 30,000 engineers who are primarily involved in automation and different aspects of the industry, more in the quote-unquote industrial space, I think probably than most of us. ISA, let's do it again, is a wireless communication standard. So you're not going to buy a box that just says on the front, ISA100.11a, see, that's why I didn't promise. But it's designed for industrial environments with the knowledge that you're going to apply it towards an IoT framework. It is similar to WiHART. Those of you who have already taken your test for CWICP, promise, get it right. Tom will take my $5 later. Just kidding, obviously. You'll notice a lot of similarities. We actually cover it in the book if you're interested. I highly suggest taking the class. It's going to really set you up to be able to succeed in understanding these technologies. Even if you're not the one who has to deploy the devices individually, you're not, let's say, configuring them, you're not having to get really deep in the troubleshooting, but it's going to really prepare you for having to work with them. And it's going to set you up to be able to look for those further details that you're going to need to really become an expert in it. Speaking of, I'm given to understand with our 2 IoT certifications, 3 with the basic one, from CWNP, there is going to be another one, TBD, sometime in the future. I'm actually really excited about it. That's just kind of my jam, though. I like the whole ecosystem. And then there have been rumors, Tom or some of the staff can confirm if they want, I wouldn't try to wring it out of them, that there is going to be an expert level and maybe something that interacts with the CWNE side of the house or CWNE side of the house, however you want to look at it. So I would also look out for that. But back to the technology. So it is IoT, kind of as we understand it, but it's more standardized. So you don't have a light pole that's talking to another light pole that can't talk to the rest of your system. It's built to be able to get that data out. One of the neat things about, to a degree, both WiHART, which you'll hear about either later or before me, I'm not quite sure yet, I don't have the schedule, is it's very similar to WiHART. So you're going to see a lot of things that come together with that. One of those things is that you have multiple architectures and options that you can go with, and it's built to be scalable. They didn't roll up into this and kind of say, well, here you can deploy them in a, let's just call it a bus, but that's it. Now, if you have a 10 million square foot plant, you can deploy ISA. You can deploy WiHART. You can take that same technology, ISA, and deploy it more or less the same without giant alterations to a 1,000-foot office. I'm sure there's some application for ISA in an office, but if you want to really stretch it out, you could say in a park. I'm not quite sure how that would work either, but maybe there's someone out there sap collecting and trying to measure that. The point being is you can adjust your deployment however you need. If you need a small deployment, you can just have the devices talking to each other or directly to a gateway. But if you have a giant deployment, you could have several gateways and you could mesh out because you don't have a single point that is acceptable. You're not going to build that nice little circle or star topology. So if you want to go with mesh, it's pretty neat. Honestly, that's just my opinion, but you have the option. So when you're evaluating this as a technology that you want to propose or you want to move forward with and you want to look at the options, I would keep that in mind because not everything is so flexible. With other technologies, we've kind of had things tacked on. If you have your basic controller and AP model, now we can really expand that. You've got cool stuff like remote sites and dealing with all that, which is, it's neat, but I don't think it's how everything was envisioned originally. The basic unit of it is still very much the AP and the clients. Go, clicker, go. All right. So this is the thing that starts off all of our jobs, right? If you call someone that is an engineer, that wants to be an engineer, that works on engineering problems, that is the seed of it, is the problem. So the first thing a lot of people ask is, well, what is the problem? And I could probably do a 30-minute presentation on getting to what is the problem in your troubleshooting sessions or when you are dealing with situations. But I'll leave that here. So we have to ask ourselves, like with anything else, what is the problem? In this particular environment, what are the problems with this environment? So I work in a more refinery space. So for me, it's rather unique. I'll show you some more in the other slide. But in refining, in heavy industry, manufacturing, any of these big places, you're going to run into some very similar issues. And the problem is their infrastructure. Most of these bigger places, campuses, whatever you want to call them, are incredibly dense. I haven't personally been to a smeltery, if that's the right word, someone correct me, forge maybe. But from what I've seen, they're very similar. So when you're in a refinery, again, this is my quote unquote home space right now, what you see is it's incredibly dense. There are pipes, there are bridges, there are walkways, there are the actual process units themselves, and we're talking about 10 million square foot, fun surveying, by the way, 10 million square foot of dense pipework interspersed with open space. And the dense pipework represents the second point highlighted here, which is that you're gonna have a lot of metal and RF unfriendly things, materials, I should say. So I'm sure all of you, or most of you, know what happens when RF strikes metal. So depending on the angle, the exact composition of the metal, where you are, the distance, blah, 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 it's going to reflect or refract off of that. Some other materials might just absorb it, like water, right? So the issue this introduces is we have to account for it when we put up our APs, and ideally when we design it, before we get to the point we put up our APs. So with everything you add, the more complicated it gets. So in extremely complex environments, that presents a problem. So another thing that's unique about these is you're going to run into way more issues with hazardous materials and environments in heavy industry, which I'm going to use to encompass all of the previously discussed things, just as a generic term. Hazardous materials, and particularly environments in refining, are everywhere. The entire plant where I work, or plants where I work, is considered, well, we'll talk about hazard ratings later, but it's all considered dangerous. They have a set of rules that apply to the entire plant and then to the individual zones, but there's something you need to know and something you need to ask about. Because if you come on one of these and you end up with a safety violation, people are going to be real unhappy. It should be your liaison, whoever you're working with at the plant structure, kind of like I believe Francois has mentioned about warehouses. You need to go ahead and get a list. And is that ISA? No, but it is something that I'd really like you to be aware of if you go out there. Some common callouts are there may be some testing you have to do, whether that be safety or let's call it physical testing. There may be some equipment you have to have. In particular in refining, anytime you're in the fence, you have to have FRC gear, which reduces the likelihood of you catching a fire or things like that. It's an insulator, right? So we come to the crucial question. 5 seconds. What's the crucial question? What's the question you have to ask all the time? Give you a hint, it's not what is the problem. That's later. What does my client want? So this one's hard. It applies to everything, every section of what we do. What does your client want? Sometimes your client may say that they want a better network. That sounds great, and that may be what they tell you, but that's not what they want, right? You can go a level deeper than that. You can say, okay, you want a better network. What are you going to use it for? Oh, well, we want everyone to be connected. Oh, so that's what they want. No, not quite. One more. Okay, well, you want everyone to be connected. Why? So they can do more work and things won't get in their way. Okay, mobility. That's generally what it's referred to. That's a good answer, but it's still not the answer. So I'll give you 3 more seconds. What does your client want? Money. That's what they're after. This is kind of a controversial take, I guess, but I haven't found an exception yet. Feel free to let me know if you find one. And this applies to businesses, right? Charities are kind of wishy-washy on this one, and I'll let you draw your own conclusions there. But what they're after is the take, the money, the income that keeps the business going and grows it. So everything comes in service to that. Some of you who are lucky enough have done business cases, you've done cost-benefit analysis, or maybe you do your own books, you've done your profit loss, you'll be familiar with this. Everything ends up centering around that particular concept. You don't have money, the rest of your business goes away. So you have to keep that in mind when you're consulting, just in general, but particularly in these spaces, because they are very, very interested in it. And if you want to win the argument about your deployment, that's what you have to keep in mind. Your business case has to be solid. Now, this, going back the other way, is made up of a few different bits. It'll generally break down into use cases, which you'll use to build your business case. And no, this is not a presentation about business cases. I'm definitely not the one to give you that one, but they're out there. But let's talk about a few of those. What can you say that your deployment is going to do to get the money? Efficiency gains. So this is a really, really big one in especially heavy industry, because a 0.001% efficiency gain sounds tiny, but when you're applying that to, say, 1 million barrels of oil, 10 million barrels of oil, suddenly it stacks up. And they know that over time, those efficiency gains are going to pay for the system that you put in. So that's definitely something to consider. ISA is actually really good at this because it can send smaller bits of data, more discrete, back from a remote environment through some of those different topologies like I talked about. They might be able to tell you a corrosion rating on something. They might be able to tell you if there's an abnormal vibration, right? So all of those lead to efficiency gains, whether that be in nominal maintenance right before it breaks down and causes a stoppage, which is also an efficiency gain, or it could just be knowing how your paint's faring. You know, there are situations in which that is actually a really big thing, believe it or not. So the other part is redundancy. And this ties in with what my next slide is going to end up being. And redundancy, no one likes to talk about redundancy. We generally hear redundancy as being a bad thing, especially in the age of COVID, right? Unfortunately, well, let's just leave that one there. Redundancies in systems, though, are good. I'm sure most of you have set up an HA pair with Cisco or Aruba or whomever. I'm not biased, I promise. That's a redundancy. And you're going to want those because you want unimpeded function. So there's a point in which you do have redundancy start to overcome efficiency gain from having that redundancy, or your risk in this case. You need to weigh that. But redundancy in data, in this case, is a really good way to sell your client. And by sell, I don't mean literally, I mean to get your idea across the table. If they have sensors out on a absolutely crucial, let's call it a tank, and this tank measures its level 5 times an hour, and they really need to know if it goes over a certain level. And you can say, okay, well, we can slap a sensor on there, and that sensor can tell you anytime it goes above that level. And it'll tell you what, we'll make it report the level the tank is at to twice as fast. Or you could report it 5 times less often. Whatever fits. The incentive here is if something fails, just like the HA pair, you're going to be able to recover that. And you're going to be able to recover it without necessarily having to immediately reach out and get a maintenance guy or whomever out there, especially if it could create a dangerous situation. It's a fantastic way to get there. So both of those end up leading you to cost reduction. Cost reduction is kind of a slippery one But in light of the other two, I don't think I have to explain too much about this one. In terms of cost reduction, you're looking for failures before they happen. It may be related to efficiency, but I wanted to go ahead and bring this one out because efficiency feels like it's related to a process that's already happening. Whereas cost reduction is more of, it's kind of a combination of efficiency and redundancy, right? It's the end game there. So your last use case, I would actually say this one is the most important, especially for wireless systems. Safety. Companies, especially in this space, are very, very interested in safety. Your safety, my safety, John's safety, everyone's safety. Not only because of the human cost, but everything else wrapped up in that. So when you're talking about these, the safety of them is something that you really should take into consideration. Now, even if you just use them for alarms, which some plants have been doing for longer, and they're just now starting to bring them into the controls space. In particular, they've been really good at alarms because you can have something out there that if one of your alarms fails, this one's going to take over, keeping people safe. And if you have a gas leak, and let's say you have an operator out there who's looking at his whatever he has and say, oh, well, there's 4% more gas than there's allowed to be out here. If you had a sensor out there, you'd already know, and it would have already blasted something back. You know, blasted the information back for clarity. We'll talk about that here in a second. But the information is probably already being acted on. You know, it's just like in Prime or some other NMS, except you can apply it to the physical world. You want to get these alerts as fast as possible. And so that's ideal with something that's over the air. You're going to get it literally at the speed of light, and it's not dependent on a physical medium. Which sometimes, well, okay, yes, physical medium, it's air, it's electromagnetism, but you know what I mean. You don't have to have someone courier it up to you, especially if you had several failures, let's say. So definitely keep in mind safety. Safety is a big, big thing in all of these industries. Hazardous conditions. I hear some of you in the back saying, oh, well, I got my MSDS training. I know exactly what these are. Well, it's not quite that. That's not what we're talking about. If you've always worked in more of an office environment or a retail environment or what have you, if you haven't worked in, I'd say, the heavier side of industry, these are much rarer in light industry. But I want to talk about two particular bits. It's the hazard class and division classification. So in my space, we have two that are mostly pertinent. And it's Class 1, Division 1, and Class 1, Division 2. The difference being the amount of time that a particular hazard is available. So if you're Class 1, Division 2, you do have to have a sealed enclosure. It has to be what they call intrinsically safe. But it's meant to be rated for an environment that explosive gas or liquid in particular, either one, is going to be present 10% of the time or less. You know, it's not that often, but often enough for you to take these precautions. Anything above 10% is going to put you in C1, D1. The difference there is you're probably going to have a vacuum sealed container, and it's got to be blast proof. It's really interesting, actually, once you start looking into how we do these containers. If you are interested, I would call some of the people who do containers, two famous ones, and I don't have a preference, it's Exceltex and Vintev. They've both been doing this kind of thing. They also do apps and that sort of thing. They do really good work, but that's not the point. The point is they can help you out with these. There are also the AP manufacturers themselves will hook you up with some of these classifications if that's what you're interested in or that's what you need. Cisco, which is what my environment works with, has just got rid of the 1552 series, or rather they're not supported anymore. You can't get any more even if you wanted to. There's actually a lot of subclasses, 1552S, 1552H, and it has to do with the add-ons and small things that have been changed, but it looks basically the same. To replace those, they brought in the IW6300s. And they're a little more modern, but the philosophy is the same. It's their industrial strength, so to say, offering. and they're going to be classified as intrinsically safe, at least for a C1D2 environment. So you need to pay attention to those. It's going to affect your AP choice. It's going to, excuse me, a lot of things. It could really cause you some issues, so get ahead of that one. And then back to the safety, make sure you're taking the precautions you have to. In my environment in particular, if it's not intrinsically safe, you're not bringing it in. And to some degree, it may not even come in the wire, much less any of these actual rated environments, because you never know when something might happen. So they're pretty darn strict about that. I mean, it's even down to your cell phone. Anything that could be electrical is a straight no. Be aware of them when you're out there and when you're suggesting things to your customer. You don't want to run into that on the back end. Excuse me. Why use ISA100.11a? Well, it was purpose-built, right? So they wanted to create a solution for these spaces. Not just refining, but again, that whole heavy industry or industry in general space. This could even extend to municipalities. There's a lot of different things you could do with it, but they wanted to hit some main points. So they wanted the infrastructure to be a lower cost than putting up, let's call it standard wireless APs, Wi-Fi, 802.11, any flavor. They wanted to be able to have redundant systems built off of them, which is a little harder, admittedly, with Wi-Fi, especially when you start cramming things together in a small area. They wanted it to be able to be put in not only diverse, used in diverse applications, but they wanted it to be able to be in places where you could not put another solution. Kind of like I was just discussing the hazard rated Cisco APs. It is, excuse me, that's what they wanted for the solution. They wanted you to be able to use it in a place that's, let's say, 600 degrees, where you can't have your nice, pretty non-plenum Ethernet cable running up the wall, right? Even if that particular area wasn't, what if you're running past one and you still have to have a wire in there? They wanted it to be more economical for you to use this solution and just, let's say, drop it in, and instead of having to run a whole bunch of other infrastructure, which is something that you really need to consider in these spaces particularly, is that anything you do, especially in a refinery, and I can absolutely vouch for this, anything you do infrastructure-wise in these plants is going to be horrendously expensive. Horrendously expensive. In particular, on my last project, we ended up canceling a fiber run we wanted to do for one of our root APs because it was going to cost us $2 million to move it about 100 feet. So, like in everything else, it depends, TM. And you're going to need to work around things like that. But that is one of the things that they were targeting, because you don't have to drill through the ground if you have something that can talk over the air and still accomplish the rest of your goals, right? So what we ended up doing in that particular situation was putting another mesh access point out in that particular area and reworking some of our routes. Point being, things can be very expensive. Speaking of expensive, you know what's really expensive? Man hours. These plants are very conscious of how many people they have in each area and how often. So one of the things that ISA, the organization, not the standard, set out to do in the standard, not the organization, was make these be able to not only be out in places where other things couldn't, but be out in places and not have to be touched. I actually had a conversation with my client and one of the engineers who represented the people who are giving us the devices. And it was really interesting to me because he asked us a question that we didn't expect. He said, how often do you expect to maintenance these? And I said, well, what, every 6 months maybe? We'll send somebody out to check on them. He said, no, that's too soon. Don't do that. What do you mean too soon? He goes, oh, you don't need to check on them that often. Okay, but we do refresh every 3 years, thinking that I was crazy. He said, nope, that's too soon. So eventually we broke down some more back and forth because he was really drawing it out, which I won't do to you. And he said 10 years. Somewhere between 5 and 20 years with a 10-year mean is where you're going to find most of these devices need to be serviced. Of course, some will break early. Some of them will be transmitting more often than normal. Some of them blah, blah, blah. but you should be maintaining them about once every 10 years, which blew my mind. I thought it was incredible. And we're going to see one of the reasons for why they are so power savvy, because the batteries aren't big. I mean, we're not talking about hooking a camper battery up to a little transmitter or anything. They're pretty compact. It's pretty impressive. I would say they're about the size of 2 Coke cans if you could make them one thing. So enough about the environment for a little bit. Let's talk about ISA, let's do it again, itself. So it has a base of the 802.15.4.5. You know it, you love it, you used it on the way in here in your headphones so you didn't have to hear me in the hallway. Just kidding, virtual obviously, but you would have. It's in the 2.4 band. I have a nice chart up there. Feel free, I'm going to make this slide deck available to you somehow, and feel free to grab that off there. I find it really useful and actually reference it more than you would think. It's a low rate, low power technology, which means you're not going to be sending any 4K videos on it. It's just not going to happen. And it's low power, which because it's low rate and you're not going to need a huge SNR, that's not as big a problem as you would think. Transmitting at 10 megawatts, wow, 10 milliwatts, excuse me, 10 megawatts would be amazing and terrifying. 10 milliwatts is fairly low for a transmitter, right? I'm sure if you're indoors, it's fine. But if you're trying to cross the field, let's say, usually that'd be pretty alarming. That is the max power for these. By and large, all the devices I use personally, or use at work rather, 10 milliwatts is about as much as you're going to get out of it. So low rate and low power, but it's not a problem because the payloads are small. You got to remember we're not checking Facebook with these. You can't, as a matter of fact. So keep that in mind. It does use different channels than 802.11 does. The widths are different, the spacing's different. Again, I'll refer you to the chart. But you need to look at it. There's actually quite a few. You'll notice that on the chart, they're numbered 11 to 26. Not all of these are used by ISA. It's actually all of those are, but there is, I believe, 50 some odd channels that are available, excuse me, for 802.15.4 devices. So once again, keep that in mind and realize who you're coexisting with. Coexistence with ISA is interesting because there is some discretion in the standard about how to do coexistence. I'm sure when you hear the WiHART presentation, it'll probably be covered there too, because they share a little bit of it, but they don't have to play quite as nice as you would think. That said, you can set it so it does, but it is a little different. Contention's actually, it should concern you more, but it doesn't concern the technology quite as much because you're not going to be contending with other ISA devices. You're going to be contending with outside interferers, like people using that 2.4 band to actually check Facebook. That's because it's not random access. That means you don't have any client demands where they suddenly need to pick up just out of nowhere and send or receive data. ISA is a pretty strict schedule, and instead of any of the random access patterns that you need to get on the medium, it uses TDMA, time domain multiple access. So that does give it some determinism, but really the magic is that you should know each sensor how often it is going to transmit. Those sensors will all report eventually to the network manager, which handles the scheduling. No, not the guy in the office. It's a role that will generally live on the gateway, but it can be discrete if you need a highly secure solution or something of that nature. So keep that in mind. It'll take all of these settings, roll them up, and create you a schedule. And then each of these devices will be transmitting whenever it needs to be, but no more than that. So you're going to add in a little bit of overhead, but they're not random, and it's going to space them out. So you should not have device 3 and device 5, since they know each other exist, transmitting at the same time on the same channel. Which, speaking of, everyone awe at the bunny rabbit. All right. That's a really cute bunny rabbit. Anyway, so channel hopping. This is interesting because most of what we work with, we're used to messing with channels in Wi-Fi, right? I mean, it's one of the things everyone wants to mess with when they get on the network. Say, I don't like this channel, I don't like that channel. I want to be on this channel with this channel place this channel time. And it gets kind of wild. Well, one of the cool things about ISA in reference to other similar technologies is that you can configure the channel hopping. It's pretty neat, actually, because you may be running several of these networks that can't talk to each other because they are discrete networks for security reasons, let's say, and you need to set them differently. So there's actually different hopping patterns you can set, 5 offhand, that you can set that it can go through. And there's also modes that you can set the channel hopping to do. You have slotted channel hopping, which is a 10 millisecond slot, time slot, that it will transmit. Each device will transmit, and then it's going to hop channel to channel. You know, your frequencies, it's going to change each time that elapses. The problem is, you have other devices that either can't hear well or they're old, one of the two, so they don't have the option for slotted channel hopping. You know, your little bunny is tired, so you get slow channel hopping. Slow channel hopping assists not only the legacy devices or the devices that can't be heard and have to adjust, but it assists devices that are just starting up to join the network, because it may be hard for them to synchronize with all of these channels. You know, you would think that during any particular hop, it would have a 1 in 15 chance of hitting it, but that's just on the frequency side. And on the time domain, you can follow each other for a while and not hit each other. So slow hopping gives you a chance to pick those up, but it's much more vulnerable to interference because it's going to stay on that same channel for a while. So keep that in mind, but if you need to recover a device, or you know you have some legacy devices that aren't that smart, or yada, 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 slow channel hopping may be your guy. What if you're afraid of commit? Well, I've got something to sell you. It's called hybrid channel hopping. You can get periods of slow for your legacy devices once they're scheduled, or to try to pick up new devices, and then get your efficiency gains on the backside with the slotted channel hopping, taking care of all newer devices, the more capable devices. With this, you should know that you can configure both the time slot and, again, which of these patterns that you can get to. So if you want, let's say 5 millisecond time slots, you can do that. If you want 20 millisecond time slots, you can do that. It's still slotted channel hopping, you know, all the way up until you pushed it to what is essentially slow channel hopping. So be mindful of that, but I would encourage you to be careful initially and see if it fits what you need before you go down that side. I'd probably put it in a nice little panel that says advanced. So contention concerns. My biggest contention concern that I've run into is actually with Wi-Fi. 2.4, it will not kill your devices necessarily, but it's going to make them retransmit, which is a whole other kettle of fish, and will impact your battery life, which your transmissions are most likely to get through unless you have some truly horrendous interference. But you have to shepherd that battery life. So you need to pay attention to it. I don't think I've seen other 802.15.4 devices step on it yet. I'm sure it can, but I'll cover a little bit of what you need to look for that here in a little bit. So routing, ISA100 or ISA is interesting. It's got a different routing scheme. So inside the subnet, the routing scheme that we all know and love, and indeed the layer of the OSI model, or the TCP/IP model that we all know and love, is not applicable. It's actually going to do the routing at the data link layer. It has a special extension for this. If you're interested in what that looks like, I would encourage you to check out the book, CWICP. It's got a little more information in there. It gets a little wild. But what you need to know is that the data link layer actually does the routing on the inside of any given subnet, any device to device. Now, when you leave the subnet and you go over, well, we'll see a little more here in a second, but when you leave the subnet, it's going to be mostly IPv6, or more precisely a 6LoWPAN sort of arrangement. What gets kind of even more strange is that the encapsulation isn't standard. Well, what does that mean? I'm so glad you asked. So the encapsulation, it actually doesn't fully reinterpret and de-encapsulate your data when it's just going from device to device. When it's going device to device, you'll encode your data on the way out, starting at layer 7 or what have you, and then shooting it all the way out to the PHY, and then back into the PHY for whoever picks it up next. But they're just going to pass it to the data link layer, assuming they're just another, I believe the term is I/O device, or it could just be a routing device. They can be the same thing, but roles are kind of tricky in both WiHART and ISA. So I'd encourage you to pay attention to those if you're trying to trace these packets, or frames, sorry. I know someone out there is furiously commenting right now that, oh, Foster, it's a frame, how could you? So device to device, inside the subnet, you're going to go down the stack, start going back up the stack, and go from data link layer over, straight back down the stack. No, you're not going to network. No, no one's busting open the data. It's just right out of here. So it gets a little wonky once you go to a network device like a router, particularly a backbone router, because then it's actually going to route it according to like 6LoWPAN, and it's going to kick it up to the network layer, and then it's going to kick it right back out. So it's still going to go up through the physical data link or MAC layer, whichever you prefer to call it, and then to the network, then to be re-encapsulated and kicked back out onto the network. Only when it exits through a gateway is it going to be de-encapsulated and then fully re-encapsulated if it's being sent somewhere else. So when it hits a gateway, which you can sort of compare to a mesh gate, in that it is the point between the wired network and your ISA network in this case, or where it feeds it to another device that needs to reinterpret it. You probably see a lot of those in the counterpart to the certification I just discussed, which deals with integration. So be mindful of that. Into or out of the network, it has to go through the whole stack transition to be re-encapsulated back into the format for ISA. Things to consider when deploying. Things, we already talked about battery life, right? So battery life is going to be your bread and butter here because these things are expensive like everything else. But if you can get them to last that 10 years, do so. If you can get them to last 5 years, do so. If it's just 2 years, do so. You don't want your customer to have any more turnover than they have to. Utilize the technology, it's low power, make your life easier, and consider your battery life. So part of that is the network you already have, where you're going to be putting these things. If you have a really hot 2.4 network, bust out your spec am, get out there, and see how things go. Because if it's super hot with a high duty cycle, it's going to be really hard. They're going to be struggling to get their transmissions through. So definitely think that through and think about how the need fits into what you have versus what you plan to do. Is it an overhaul and right now it's noisy, but in 2 years it won't be? Make your call based on that. It all flows into your business case, which is really going to drive all of this. I know I probably beat that one to death, but it's been beat into me to death. So just keep that one with you. My suggestions for implementing. Survey, and survey. Do your surveys. Why do I say that? Well, it's still RF. You can still see it. And if you wanted to just go by the RF energy, your survey will help you. It's going to show you what's out there. You could fairly well simulate how far that same energy is going to go with a little bit of cleverness and the APs you already have, or APOS, blah, blah, blah. Just make sure you're looking for the right data rates and consider that it is a low power, low rate network. This is going to give you a lot more insight into the network you already have. So if you did a survey last week, you'd be all right. I would replace it with, excuse me, I would replace it with a spec am shot, really, because that's going to be what's going to kill you. And keep in mind that even though it is a low power and fairly high range network compared to like wanting 4K video on your network, just don't overstretch it. These are designed to be meshed together over long distances, so don't take the risk. So those encapsulation, those enclosures I mentioned, some people have gotten clever, especially for the ISA devices as opposed to the APs, because APs is what I was talking about earlier. And they're already intrinsically safe casings. These are Honeywell devices. These are the ones that I used in this particular case. So I would just say, keep that in mind. The one you see on the right there is their bolt-on model. It goes with the IW6300 that I mentioned from Cisco. They're interesting. Emerson has one too. I believe that's for WiHART only though, so keep that in mind. But you know, get creative with it. But you need to understand the environment you're working in. If you don't need intrinsically safe equipment because you're working in, let's say, a warehouse, then don't bother about it. Yeah, that's about it for me, guys. I appreciate you listening. Hopefully I'll see you at the Q&A here in just a few minutes. And I hope you're gonna keep yourself safe and everyone be well. Go out and do great things.
All right, Landon, here we are live and in person. Where are you located at right now?
I'm in Fort Worth, sir.
Fort Worth.
Yeah, beautiful Texas.
So yeah, we're coming to your neighborhood next year, hopefully, right?
Oh, I'm very excited, actually.
Yeah, that's the current plan. You got to go home every night, can't you?
I mean, I could do that, but I don't think my wife is going to want to pick me up at 2 a.m.
There you go. All right, so ISA100.11a, it's a really cool protocol. To me, both it and WireLessHART are a couple of the most interesting protocols in the CWICP track. Yep. And the whole concept of the super frame is the one. Of course, it's defined in 802.15.4 now as well, but it's actually implemented in a little bit of a unique way in 100.11a and WireLessHART. For me, that's kind of the coolest thing about it, the way it does the super frame scheduling. But I thought, you know, we'd see what's your take when you're studying this protocol. What did you find to be the most intriguing, interesting thing about it?
Really, and I mean, maybe this is kind of a non-answer, but I think it's the wide nature of its applicability. There's just so many things you can do with it. Yeah, it's a low information protocol, but it opens up doors that Wi-Fi really wouldn't have access to without an extreme specialist deployment. You know, if the refinery environment's a great example of that. You know, if you're on the side of, let's say, a catalytic cracker, you're just not going to be able to put a device there unless it's completely enclosed, and you're not going to be able to run infrastructure to it. So if you have something that's battery bound that you don't have to touch for 5 years and can get the data out, you know, 100, 200 meters, that's a dream.
Yeah, it's pretty cool. And let me just say, because we just had a very limited time to be able to talk and chat here and bring you live to everybody today. But I said this to so many people over the last few months: a super frame is not a frame. That's the most important thing you can go away with. If you want to know what that means, of course, take a look at the standard, take a look at CWICP. You'll see more about it. But Landon, I appreciate you putting this presentation together and joining us today. I look forward to seeing you in person again. Thank you.
Thank you.